Download this code from codegive.com, link in the description below. Understanding many-batch gradient descent in neural networks. When training neural networks, one of the key decisions you'll make is how to optimize the model's weights. A popular approach to this is stochastic gradient descent, SGD, which can be done in three main ways. One batch gradient descent uses the entire dataset to compute the gradient of the loss function. This can be very slow and requires a lot of memory for large datasets. 2. Stochastic gradient descent uses only a single training example to compute the gradient. This introduces a lot of noise in the learning process, making convergence less stable. 3. Many-batch gradient descent uses a small random subset, many-batch, of the training data. This approach balances the advantages of both batch and stochastic gradient descent. Why use many batches? 1. Efficiency. Many batches allow you to take advantage of vectorized operations in libraries like NumPy or TensorFlow, making computations faster. 2. Memory management. Many batching helps manage memory usage since you don't need to load the entire dataset into memory. 3. Stability. The noise introduced by using a mini batch helps the model escape local minima and leads to better convergence properties. 4. Regularization. The inherent noise in many batch gradient descent can act as a form of regularization, potentially improving generalization. Implementing many batch gradient descent. Let's implement many batch gradient descent in a simple neural network using Python with NumPy. Step 1. Create a simple neural network from scratch. We will create a simple feed-forward neural network and implement many batch gradient descent. Explanation of the code. 1. Initialization. We initialize weights for the input to hidden layer, W1, and hidden to output layer, W2. The weights are initialized to small random values. 2. Forward pass. We compute the output of the network using a forward pass. The ReLU function is used as the activation function. 3. Loss calculation. We compute the mean squared error between the predicted and true values. 4. Backward pass. We calculate the gradients using backpropagation and update the weights. 5. Training loop. In the training loop, we shuffle the dataset and create many batches. For each mini batch, we perform a forward pass, compute the loss, and perform a backward pass to update the weights. Conclusion. Many batch gradient descent is a powerful technique that can significantly enhance the training of neural networks. By using many batches, you can strike a balance between the computational efficiency of batch gradient descent and the robustness of stochastic gradient descent. This method is widely used in practice and is fundamental to training deep learning models effectively.